for like 30 minutes. And then I was doing homework. So that's fun.
Okay, getting started. We are going to talk about geologic time today. And this can be really a really touchy subject because we have a traditional belief in Ussher's chronology. Certainly, you know, Ellen White supported Bishop Ussher's chronology. So before we go over this, let's talk about briefly what Ussher's chronology is. How many people are aware of the name Ussher's chronology? Okay, good thing I'm starting there then. So Bishop Ussher wrote a series of books. The name is something like Annals of the History of the Earth or something like that. And he tried very diligently to make a timeline going from the beginning of the Bible to the present. And so in the Bible, you have genealogies, things that say, and Adam lived so many years and he begat Seth, his third son. And he lived so many more years, and the total number of his years were this. And then Seth lived so many years and he begat Enosh, and then he lived so many more years for a total number of this years. And it goes through like that through a number of generations down until you get to the flood. And so he took those numbers and added them up to get the time from Adam to the flood. And then from the flood, well, there's a few genealogies to go on after that, but then he starts going from major events to major events, because you have things in the Bible that say, you know, from this event to this event was so many years. And then using traditional records, once he got to a point where you could use traditional records, he moved forward to the present day. And so based on this work, now there are a few assumptions like, okay, so we don't know how long this guy lived, so let's take an average lifespan for him. And there's, of course, the assumption that the age is given and the date, you know, time stamps given are accurate in the Bible. He comes to about 6,000 years ago when creation occurred. And not only does he come to about, he came to an exact day. He said the Jewish calendar starts the new year on October 23. And the only reasonable reason to start the calendar October 23 would be if that was the day of creation originally. And so he said that creation must have occurred October 23, and you know, he has a year there. And so that's where we get the roughly 6,000 years old for the earth from. Right? So it's not a number that's pulled out of thin air. It's a number that was very carefully determined. Now, lots of scholars have gone back and gone over the work, and you have some variations in what people get, but they're not big. And you have other things like, how do we know the dates in the Bible for the age of these people are correct? There is a known fact, if you look at the Egyptian king list, that kings that were popular, their reigns are listed as longer than they really are, as determined through archaeological excavation. And kings that were unpopular, they may be skipped completely, or they may have their reign shortened to make it look like they were a much more minor character. So there's some variations that you see in historical listings of ages of rule. And so you could have had a similar thing like that going on. So a lot of people will say, okay, let's assume this was going on. If you set 10,000 years, you know, any biblical reading is going to say less than 10,000 years. And so I think it's real comfortable to say most young earth creationists, you know, under 10,000 years, ballpark of 6,000 is where they come. So when we look at geological time, that is not the starting point taken by the scientists interpreting the rock layers. Remember, everything is interpretation. Ussher's chronology was interpreting the Bible. Some people say the Bible wasn't meant to be a record keeping for time. And so there is no strong reason to suggest that the dates are exactly on, which, like I said, give the wiggle room. But then there's other things like, How long did Adam and Eve live in the Garden of Eden before they were evicted? Is Adam's age starting from the date of creation or from eviction from the Garden of Eden? And you have other questions like that. So, we can't biblically come up with an exact date if we take every word of the Bible is exactly correct. We still can't come up with an exact date for creation. The scientists start with something that I don't believe. I know I'm a scientist, but they start with the belief that everything that has ever occurred in the history of the earth occurred naturally. What does that mean? Say that everything is natural. Go ahead.
Doesn't it mean no outside force intervention, nothing with God?
Exactly. No intervention. So it doesn't say there is no God. So we shouldn't say that the scientific starting point is atheism, but it is that God doesn't cause miracles. Right? Because if God caused a miracle, that is the definition of unnatural. And so they start by saying there's no miracles. And then they say, given that there's no miracles, the things we see going on today should be able to explain the things that we see looking historically. So what kind of things do we see going on today? Well, we talked about what's going on right now throughout much of Nebraska. What's going on right now? Flooding. And so flooding is going to cause more material to be weather eroded and then deposited. So we can have floods. What goes on normally? Much less effect, right? Normally the streams are going slower. They don't pick up as much. They don't carry as much. They don't drop as much. And we have earthquakes. We have volcanoes. So those kinds of things are what they use to interpret the data. We call this method uniformitarianism, which is pretty obvious when you have the name. It means that everything is behaving in a uniform manner. What about people who believe in a young earth creation? How are they going to interpret?
Well, they would probably say, well, we don't necessarily know what the conditions were back then, and it's not necessarily all the same, especially with things like the flood. Scientists who have the no miracle, I forget what you call it, philosophy, naturalism. Yeah, they wouldn't think, global flood, because that doesn't normally happen today. So they're not going to think, there was a global flood that turned the waters out of the fountains of the deep and
I think
they wouldn't see things that way.
I think it's hard for them to explain to people that don't necessarily believe that the flood happened, because there's not enough water on Earth to cover everything, even if the ice caps did completely move.
Mm-hmm. That's a strong go-to argument. Go ahead.
No,
Well,
I was just gonna say evaporation, water evaporation.
Their argument says there's not enough water, including the water in the clouds and in the sky. Now, if the Earth was a perfect sphere, there's always going to be enough water to flood it, right? If there were no mountains, just by definition, there would always be enough water to flood it. And so a traditional Christian response would be, the mountains were created at the start of plate tectonics, which is at the start of the flood. And so you didn't have mountains beforehand. It doesn't take nearly so much water to flood the earth. And B, water below the surface. And then you say water below the surface. I told you earlier about the diamonds that are known to come from down the asthenosphere that show evidence of water in the environment when they were created, which then is used to project, and this is not by Christians, by the way, it's by traditional scientists. It's used to project that there is an enormous amount of water that is down under the crust. And so, a Christian can then incorporate that and say, okay, so that's more water that could have come to the surface during the flood and then been taken down because of all of the upheaval, or could have been, So it's a strong argument made by naturalists. it's an argument that is countered in ways by creationists. Can't remember what we were talking about before you brought that up. I've got that steel trap mind. So when it comes down to the brass tacks, we have certain data. We dig up rocks, that's the data. That's immutable. We can't say, oh, that doesn't exist. And I have to point out, when I was a child, my parents said dinosaurs didn't exist. When you see dinosaur bones and fossils, that's made up by the scientists to deceive us. That was not an uncommon belief when I was a child. And now most people, well, no, there's plenty of fossils down there. So we have that evidence, and it has to be interpreted. And the young Earth creationists start with, radiometric dating must be flawed. If radiometric dating is not flawed, then everything breaks down for a young Earth. So it must be flawed. How is it flawed? There's a lot of people trying to figure out different ways it could be flawed. And then, assuming that radiometric dating is flawed, then we have a lot of water in a short amount of time causing almost all of this geologic record. And so everything is interpreted saying you have a lot of water. If you have a lot of water, a flood, then you're going to have a lot more erosion, a lot more sedimentation, and so you build up lots and lots of layers, and that's the explanation given by young Earth creationists. Whereas uniformitarianists say, there is no evidence for a worldwide flood. You can look at places like the Barringer meteor crater in Arizona, which appears to have had no water covering it in at least 150,000 years, and say, well, if there was a worldwide flood, it would have had to been a lot older than what the Usher's chronology says for a flood. And so, if there's, you can't explain things by the flood, then you have to explain it with uniformitarianism. So I just want to make sure that we have this background covered. The last thing I want is people to go out. I actually watched a Ken Ham thing this last weekend about the things that Christian scientists are saying and how they are, not congruent with his beliefs as a young Earth creationist. Ken Ham is the guy with the Creation Museum in, was it Petersburg, Kentucky? The one that has now a Noah's Ark.
Yeah.
You been there?
My dad went.
We went there for a Creation Evolution conference. Oh boy, 6 years ago now, something like that.
Wait, to the debate thing?
No. Long before the debate, it was with Bill Nye, the engineer.
Wait, he's an engineer.
Huh?
He's an engineer.
Yeah, he's not a scientist, but he's an engineer.
He's like an entertainer.
Yeah. Okay, so getting into the rock record. So we have two ways of dating. We have relative dating and absolute dating. Relative dating is not, hey, my cousin over there. Relative dating is, I know that's pretty sick, right? Although looking back, genealogy, my grandfather's half brother married his first cousin, and so, their kids are both my half second cousin and my full third cousin.
Are they normal?
Yeah.
I think it takes like a couple of generations to stop the curse.
Going way off topic, just because we're talking about this for some stupid reason of me using relative dating, making a joke. The reason inbreeding, marrying a close relative, and producing children, of course, is dangerous. The question about normal is because recessive traits. There's a lot of bad things that we carry as recessive traits. That is, I carry a bad trait. If you carry that bad trait, we can give it to our kid and they can have a bad trait. If I carry it and you don't carry it and it's a recessive trait, our kid's going to be fine. And so if you have close relatives, they're more likely to carry the same recessive traits, and that's more likely to pass that trait on as something that actually manifests in a child, even though it didn't manifest in either parent. And so we Scandinavians have, I carry my mom got it from both of her parents, so it's a dominant trait for her. Her first cousin has the worst possible form of and had to have an organ transplant last year because of it. So That's why it's bad. Question?
I have a kind of a dumb question. No, like it really is.
Okay,
How,
totally stupid joke on that. You guys have heard, there's no such thing as a dumb question. Only dumb people who ask them. That's a dumb joke. You're not a dumb person. What is your question that is not dumb?
okay, so isn't the sun like 5 million years old? How is the Earth?
Okay, so the dates. I will answer that, but let me first talk about relative dating before I talk about absolute dating.
Okay.
So relative dating, when you look at layers, we can date them by, well, this one's under that one. And we have a principle, a superposition, I think is the name of it, that says the things that are lower are older. The things that are above are younger. And so we can go through and we can put a sequence to the dates just by which ones are higher than the other. And so that's a relative dating. And absolute dating is when we actually try to put a time to it. And so this here has shrinking down to try to get some idea of where we are in Earth's history. But Earth's history is believed to be about 4.5 billion years old. Depending on who you read, you'll see some people say 4.3 billion. I usually go with 5 billion, just round it off. How do we get the age of the Earth? We get the age of the Earth by looking at the oldest rocks that are found on Earth that are believed to be Earth rocks. And those oldest rocks found on Earth that are believed to be Earth rocks are about 4.3 billion years old. And so that gives us, the Earth has to be older than 4.3 billion. Now, how did they get to 4.3 billion?
Acid?
The what?
Carbon dating?
Okay, not carbon.
Atmosphere.
Carbon dating can't date anything older than about 50,000 years. Carbon dating to a person who believes in these long time frames is absolutely irrelevant. It's only going to be very modern things that carbon dating can even date. But radiometric dating has other types of dating that you can use. So it's still radiometric dating. And we as creationists, we spend a lot of time talking about carbon dating because if you believe that the Earth is less than 10,000 years old, carbon dating is absolutely relevant. Because carbon dating can go out to about 50,000 years, so it's only 10,000 years old. Carbon dating can date the entire history of the Earth. Whereas to an evolutionist who believes the Earth is about 4.5 billion years old, going back 50,000 years is just a drop in the bucket. Okay, so it's using radiometric dating that they get that. Now, the question that was asked was, if they believe the sun is 5 billion years old, why would the Earth be 4.3? We're going to be doing astronomy next, and the theory on how the Earth got here, according to scientists, is called the solar nebula theory. That there was, there's a big cloud of gas, that's called a nebula, and that cloud of gas was hit by a shock wave that made it start compressing. And as it compresses, things get closer together. Gravitational force is our ultimate force. What happens to the gravitational force when things get closer? It strengthens. And so when that shock wave makes things get closer, the gravitational force gets stronger, and it continues to collapse under gravity. And so most of the material collapses at the center, and that's what formed the sun. But there are other clumps that formed, and that's basically the other planets. So we should have formed the same time as the sun. And so that was the basis of her question, why are the dates different? The dates have some wiggle room. I mean, like, when is its birth date? Is it at the start of the collapse? Is it when it reached a certain size, because of course it grew from small to larger to larger? Is it when it froze? And I think when it froze is the date that was used. Well, when it froze would give you around 4.5 billion years. Yeah.
The thing I'm confused about, like you said, it's when it froze.
Yeah.
But like if like everything like I was kind of confused about what you said. But like if a rock came in and like hit the Earth or whatever from like outer space, like and you measured that rock, wouldn't you be measuring wherever the rock originally came from?
Right. And so the
oldest
rocks found on Earth are older than 4.3 billion years, but they're not believed to be from Earth origin.
So how do they know? Or like even like with the coming together thing or whatever, wouldn't you be measuring the original age of the rock, not when it compacted?
Well,
And how
when
do you
you're
know-
when you're using radiometric dating, you're measuring the age from when the rock froze until the present. Now, this pushes back the question a little bit. How do we know the age for the sun? And that comes from a few different lines of reasoning where the sun falls in the HR diagram, the mass of the sun. There's a number of things that go into giving us the age of the sun. And that's something we can talk about when we get to astronomy. So, go ahead.
There are arguments that those people that believe the gas is compressed for how they formed all the different solids we have on Earth, and water, and even trees and life and that sort of thing.
A very broad question that easily could take the rest of the school year to answer fully. But to put things in short, so we're going to go through the whole Big Bang Theory here in 5 minutes. The theory of the Big Bang starts with a miracle. It starts with a miracle, which exactly, they don't believe in miracles, but it has to start with a miracle because the Big Bang has to start with suddenly energy occurred. Right? There was nothing, and then there was a big burst of energy. And the best answer for that is a bad answer. I'm just not even going to go there because it wouldn't make sense, and it doesn't make sense even if you understand the physics. So it starts with this sudden energy deposition. Some people propose, well, maybe we had a bouncing universe. So there was a universe before us, it collapsed, and that's the source for the energy. That only pushes the question back to where is the energy for that one to start. So you have this enormous release of energy, and then the universe expands, and as it expands, energy can form mass, because mass is just a form of energy. And so you have mass form, and you form protons, and you form electrons, and as things cool, you can have protons collide with protons and create helium, but there's a problem after that. You basically, the theory is you're going to be colliding hydrogen and hydrogen, or hydrogen and helium, and so you're adding one atomic mass unit at a time, one nucleon. You have a stable element with one proton, that's hydrogen, stable element with two things in the nucleus, a proton and neutron, that's deuterium or hydrogen-2. Two stable things with three, you have tritium, hydrogen-3, that's a proton and two neutrons, or helium-3, that's two protons and a neutron. Stable thing with 4, helium, 2 protons, 2 neutrons. No stable thing with 5. So in the process of creating elements in the Big Bang, it basically stopped at helium because there's no stable element with 5 things in the nucleus. Now, you can have the random rare event of having something larger than hydrogen hit something larger than hydrogen. And that could create another stable element. So you can go on to 6, 7, but then there's no stable 8. And so that's the second stopper. So the first stopper, you drop by like 100, 1/100th of the amount larger than helium. And then the next one you drop again, and there's virtually nothing created at the Big Bang that's bigger than what helium, I think. It might be beryllium. I can't see from this far back what the atomic masses are. So where does everything come from? That was Bryce's question. Well, when stars are living, what's going on in our sun right now according to our best understanding?
Burning gases.
Okay, burning is something we often say, but it's not burning, because burning means combustion. It's fusion. It's fusing hydrogen to form helium and producing enormous amounts of energy through this fusion. It's basically an atomic bomb, but it's controlled by gravity. And so the sun is converting hydrogen to helium, and when the sun runs low on hydrogen, well, that reaction is going to slow down. But then it will reach a high enough pressure and temperature that you'll have heliums merge together. Now remember, you can't just add a hydrogen to a helium. It doesn't work. There's no stable 5. But if you have heliums come together, 2 heliums coming together would make 8, and 8 doesn't work either. But if you have 3 heliums come together, that makes carbon. And so they call it the triple alpha process. 3 heliums come together. Our sun will eventually fuse these heliums in the triple alpha process and create carbon in its core. And it might merge some carbon with some helium and make oxygen in its core. And that's the end of it. Our sun is not going to make any elements bigger than carbon and oxygen. But for very massive stars, the massive stars can actually fuse things all the way up to iron. And so elements on the periodic table going all the way up to iron can be created in stars while they're in their dying stages, the very tail ends of their lives. So the fact that we have these elements on Earth means that we're created from stardust. We're created from atoms that were created in stars during their dying phase. Now I said only up to iron. We have elements higher than iron, gold, right? That's only created in the collapse of a supermassive star when it dies, when it has a supernova. And so the fact that we have things like gold means that we are created from material that there was a supernova near our nebula before we formed, so that we have those elements. So that's the answer to where all these atoms came from. Very interesting story I love to tell. Fred Hoyle, I believe his name is Fred, was studying nucleosynthesis, this process of creating the elements. And Fred was already famous at this point because Fred denied the Big Bang. Why would somebody deny the Big Bang?
Because you need a miracle version of it.
That's right. He was an atheist. And he said, you can't have this without a miracle, without having a God. And so he refused to accept the idea. He came up with the term Big Bang as a pejorative, saying, so where did they say it all started with? Just some Big Bang? And the scientist said, that pretty much sums it up. So that's actually where the name the Big Bang came from. So he was studying carbon specifically and the stability of the carbon nucleus. And in his research, he came to the conclusion that carbon could only exist if you had an energy level in the nucleus of carbon that was exactly this. Anything away from this, and it can't exist. And then in measurements, he found that it actually had that energy he had predicted. And he said that is too bizarre to just have occurred by chance. That there had to be a God to actually create the rules such that carbon would be able to exist. Now, he never became a Christian. I'm not trying to say that. But he changed from being an atheist who rejected the Big Bang Theory because it would require God to being a theist because he saw that carbon existed and couldn't see that there's any logical way for random chance to have allowed carbon to exist.
So did you believe in the Big Bang after that?
No. His theory is a very interesting theory. So then after that, to continue on Bryson's question, how do we get things like trees? They believe, notice I say they, I can't even present this with the objectivity of a scientist. They believe in what we call abiogenesis. That is, without life, genesis is life. And so they believe that if you have the right chemicals present in the right environment, you can have life form. And there are certain experiments, like you might have heard of the Miller-Urey experiment, where the scientists in Chicago, University of Chicago, I believe, they made a mixture of different chemicals, and they put them in a sealed chamber, and they had a heat source here, and they had electrical source here, and they let it sit for a while, and then they examined what was in there. And they started with only non-living things, as we say, inorganic things. And they found the backbone of life, the amino acids that are necessary for all life. And so they had formed chemicals necessary for life from originally chemicals that are not life-produced chemicals. This is considered saying you can make. And then I think his name is Stanley Fox has done a lot of experimentation on polymerizing those amino acids, what's necessary to make proteins, and on making films, membranes, and he's been able to show that you can do these things. But it's not without problem. For instance, the environment necessary to create the amino acids is the reverse of the environment necessary to polymerize. So you would have to make these amino acids in this environment and immediately have them transported to this environment so that they can polymerize. And so the process it is scientifically shown that you can make amino acids. It's scientifically shown that you can make membranes. That you can polymerize, and then from those polymers that you can make membranes. What is still completely unshown is that you can ever form anything resembling life. You can take a living cell, extract the stuff from that living cell, and kill it, if you will, and then inject it into another membrane you create. It's never going to come back to life. Right? We have no way of making that life, but they have to believe. There is a huge faith factor in believing that the life happened. And evolutionists will tell you, well, we have absolute proof that it happened because we're here. How else would we be here if it didn't happen? And of course, you and I would say, well, a God, a miracle, something that was not natural. But since they start with there is no unnatural event, their proof that it happened is that we're here. So that's my 5-ish minute answer to your very, very large question. Hopefully that helps you understand. Yeah. All right. Looking at the relative, if the Earth, the entire history of the Earth as we understand it, fit into 1 year, then dinosaurs would have occurred in mid-December. The first life of any kind is in March. There's a lot of questions about when the first life actually occurs, but that would be the earliest. Homo sapiens. We are Homo sapiens sapiens. We're thinking Homo sapiens. Occurs at 11:50 p.m. on December 31. That tells you where we are in the history of the Earth according to the scientific perspective. All of humanity fits in the last 10 minutes. Well, humanity, the last 10 minutes. Human history, what we have recorded in the last minute, if the entire Earth's history was in 1 year. I like this graphic because it helps you to see how it lays out. So we have the earliest pic, and notice here, 4,527 million years ago. The MA here it's actually mega ages. That's what it stands for. But mega is million, ages is years ago. So it's easier to say million years ago. And oftentimes you have written MYA for million years ago instead of mega ages. So this says the origin of the Earth is about 4.6 billion years ago, not the 4.3 that I had in the previous one. Right? Different people put different numbers. And then the moon is 4,527 million years ago when it formed. And we'll talk about that when we get to astronomy. I've already spent way more time. I'm going to have a hard time finishing today's lecture for sure. This period here, Hadean. What does Hadean sound like? Hades. And that's what it means. It was hell-like. So describe a common description of hell. Description. Okay, that was a bad word. What's a common description of hell? Burning. Hot. That's the key here. That Hadean period is when you had like a hot molten earth. Right? So we're not going to have any life during that Hadean period. Then about 4 billion years ago, the GA is giga ages. We have the beginning of the Archean. What does arc mean to you? Like archaeology? It's actually not rocks. It is a word about old. Archaic, right? So the Archean is very old, and the earliest start of life would be here in the Archean period. And this suggests that photosynthesis started about 3.2 billion years ago. Then we get the Proterozoic. Proterozoic is the beginning of more advanced life. Now, this advanced is still very basic. That's 2.5 billion years ago. Then we have the Cambrian explosion right here, 541 million years ago.
How do you know it's the Cambrian explosion?
How do I know?
Yeah, because it's not on the picture.
Yeah, but I have studied a little. So the Cambrian explosion is the time when the variety of life suddenly explodes into a huge variety. And then we go through the more common eras here, the Paleozoic, Mesozoic, and Cenozoic. Paleozoic is the old one. Mesozoic is the middle one. Meso is middle. Cenozoic is the recent. So the names are reasonably meaningful. You see here it shows the Cambrian explosion right there. It's 530 million years ago.
Where's the Jurassic?
The Jurassic is in the Mesozoic. The Jurassic, you have the 3 periods there in the Jurassic, or in the Mesozoic. And so let's get to that. I've already talked about uniformitarianism, talked about relative dating and absolute dating, which uses radiometric dating to get there. Superposition, I already mentioned superposition, the concept that the things you see in a higher layer are younger than the things you see in a low layer. We also have original horizontality. Original horizontality means that when we're looking at the layers of rock, those layers of rock almost exclusively form in ocean or lake floors, which are pretty much horizontal. And so we make a starting assumption that the fossils were laid down, or the layers were laid down horizontally. So we find them tipped and stuff. They weren't tipped when they were laid down. They were laid down horizontally. These are assumptions used for interpreting. And then cross-cutting. In lab tomorrow, we're going to be looking at this. This is what we're doing in lab tomorrow, is looking at this. Cross-cutting is when you have one layer cutting across another. Well, if you have one layer cutting across the other, the one that got cut is the older one. The one that cuts through it is the younger one. You know, like if you have a cake and you have a slice through it, you know the slice is younger than the cake is. So those are 3 assumptions used for interpreting the rock data. Some words here. An inclusion is something different that's included in something else. So it's an older rock included in a younger rock that formed after it. Lateral continuities, things should be the same as you move out. Faunal succession is one life follows another. Here's a picture illustrating original horizontality. That's how we believe the layers were laid down. And then we have, this is next, okay. During mountain building, you have plates coming together, subducting, causing compressive stress to make them crumple. And so you have the visible crumple zones. Just like if your car's ever been in an accident, you can see crumples on the metal. That's what's going on here. So you can see the originally horizontal layers are now at different angles depending on where you look. Now, erosion is always a part of the story. Some layers, and creationists who they know a little and not a lot, will say, well, these geologic layers you're talking about, they don't occur everywhere on Earth. Some places you go from layer A to layer J. And in other places you go A, B, C, D, E, F, G, H, I, J. What gives? Well, the scientific understanding is that makes perfect sense because you're going to have periods of erosion. So if you've made those crumple zones and then it's above water, you have over time, wind, animals, water are going to erode the high spots and deposit low spots. So you can see here that we have layers that are worn down and new layers that are forming from that erosion and then deposition. So that's how layers can be disappearing and you don't have the same layers everywhere on Earth. And then you can have new horizontal layers placed on top of those. And so you look here and you see at this point, we have a layer that just disappeared. And this layer here is only in this small region because it formed in between the first layers being formed and then erosion and the next layers. So it's not straightforward in interpreting the data, but we have some basic rules for how scientists using uniformitarianism will interpret. Now, if you're a creationist, you basically follow the same rules, right? You don't say, oh, no, it's a completely different story for how these things work. The difference is the time it took. The creationist says, this here took 3 days. I'm just making up a number. Whereas the evolutionist says, this here took 30 million years. Very big difference in those two interpretations. The creationist says it took 3 days because you had just so rapidly flowing water, you had enormous amounts of sediment being carried down and deposited all quickly. And so that's how it occurred quickly. Here's a picture showing cross-cutting. So looking at this picture, which rock, we have 3 dikes, A, B, and C. Which one is the oldest? Okay, I have an answer of C. It's correct. How'd you come up with that, Bryson? Okay, C is cut by B. So that means C is older than B because it's cut by B. But B is cut by A. So that means A is younger than B. So A is younger than B, B is younger than C, thus C is the oldest. Does that make sense? Good, because like I said, something we're going to be doing in the lab tomorrow. I want you to be prepared. I talked about carbon-14 dating and how it's really not useful for geology. Here, if we look at the half-lives, the half-life of carbon-14 dating, 5,700, I have 60 years here. It comes from my textbook. 5,730 is what I usually see. So there's so little carbon-14 to begin with that after about 10 half-lives, you're going to have no carbon-14 remaining. That's why it's only good for about 50,000 years. Potassium-argon dating has a half-life of 1.3 billion years. That means in 1.3 billion years, the amount of radioactive radioactive potassium is going to be half of what you started with. And after, take 1.3 billion times 2, after 2.6 billion years, you'll have 1/4 of what you started with. After 3.9 billion years, you'll have 1/8. Those are percentages that allow us to easily date throughout the entire lifetime of the Earth. Yeah?
How do you know what you started out with?
Okay, very good question. How do you know what you started out with? We have the same question with carbon-14 dating. How do we know what we started with there? With carbon-14 dating, we can calibrate in a reasonable fashion. We have things that we can date other ways. Things like you find a tree and you count the tree rings and you say, wow, this ring was made this long ago. You measure what the ratio is now and then use that same equation. You can extrapolate back to how much it had when it died. And what they're doing with carbon-14 dating is they're actually measuring the ratio of carbon-14 to carbon-12. And so they say, this is what the ratio was back then. And so they make a nice calibration curve. And it's actually really complicated and really carefully done.
Okay, so that applies to carbon dating, but
not to the others. So to things like potassium-argon dating, they look at different minerals within a rock. So we've studied the minerals, right? The minerals are the little crystals, like in granite, you can see, oh, there is a plagioclase crystal, and there is plagioclase, I can name offhand. I'm very bad at this. But you can see the different crystals, and they will measure the ratios between 3 isotopes, actually, in each of the different minerals. And from the ratios in multiple isotopes, they actually can extrapolate to what the original concentration was and get the age. It's a more complicated method. Some sophisticated, but it seems reasonable. It's something that I've looked at carefully and it makes sense. It can be broken. If you take 2 different sources and mix them together, you can get a different age. So it can be broken, but it seems like a reasonable method. But nobody can go back and actually measure them. Other things can be used, uranium-238 and uranium-235. Uranium-235 has a short half-life, comparatively speaking, 704 million years. Uranium-238 has a long half-life, 4.5 billion years. Because uranium-238 has a much longer half-life, there's a lot more uranium-238 out there than there is 235. But if you want to make an atomic bomb, you need uranium-235. So when you hear people talking about enriched uranium, it's uranium that has a higher level of uranium-235 so that it can be used for a bomb or for a power plant. Okay, so these are different isotopes that are used, not the only ones, for radiometric dating. Here is a much better picture in terms of getting times of the geologic periods. So you have the Precambrian time broken down to Hadean, Archean, and Proterozoic. And then you have, and notice this has 543 instead of 541, made at different times when they have different best estimates for when the Cambrian explosion occurred. Then you have Cambrian, Ordovician, Silurian, Devonian, Carboniferous broken into Mississippian and Pennsylvanian, Permian, Triassic, Jurassic, there's the Jurassic you're asking about, Cretaceous, and then finally Tertiary and Quaternary. Now, what do you need to know was a question that was asked.
Oh, yeah. Name the periods of the Paleozoic era.
Okay, so what are the periods of the Paleozoic? That's these here, COSDCP.
Why is the...
You don't have to separate the Pennsylvania and Mississippi. What?
Why is it only, like, because Pennsylvania and Mississippi, those are like state names. Why are those like
many of these are named after where things were, Cambrian is named after where the first of those were found. I believe Ordovician is where the first of those kinds of fossils were found. And so Mississippian and Pennsylvanian is the different types of coal found in Mississippi and Pennsylvania. What's in that is what gave it the time thing. Carboniferous is a heavy coal period. And so you just need to know Carboniferous. You don't have to break down to Pennsylvania and Mississippi. Okay, so you should know, and you should also know these here for the Mesozoic. The Cenozoic is really simple. Tertiary and Quaternary, third and fourth. So you should know those. At the very least, know this date here, which I'm going to use 541 million years ago for the Cambrian explosion, where it goes from the Precambrian to the Cambrian. So at the very least, know that date, because that's kind of an important one. That's when life proliferated on Earth.
So we don't need to know.
So know these names, but don't memorize all of those numbers that go with them.
So do we need to know the epochs or epochs?
No, you don't need to know anything beyond this level.
Okay, but we need to know everything.
But yeah, know the stuff to the left of that. Which the hardest part is knowing the Paleozoic. What was that?
And what happened?
Yes, and what happened in them is the rest of the slides that apparently I'll be showing to you in lab tomorrow.
Yay. I predicted it.
We had a good